As car manufacturers continue to add more and more technology to the main infotainment system of the vehicle, it becomes more and more difficult to simply swap out and replace that infotainment system with an aftermarket solution. If we can't replace the radio, can we still achieve far better sound and improve our car audio system? Luckily, the answer is yes. Even if we have a super complicated factory audio system, with the proper knowledge, we can still make an upgrade. Now, of course, there are many different ways to go about this, but this is what we in the car audio industry call OEM integration. In other words, we're going to keep that factory infotainment system that has all of the vehicle's settings, but we are going to integrate with that system in a way that allows us to take that factory audio signal and properly adapt it to our aftermarket gear. Now, if you've dabbled into aftermarket car audio at all, you're likely familiar with one of the most basic OEM integration options, a LOC or a line output converter. This simply takes the signal from the speaker wires in your vehicle and converts it to a low-level signal that can be used with RCA wires in order to send signal to your DSP or amplifiers. But in this modern era, there is much more to OEM integration than the line output converter. And if you don't know the basic terms, you're going to have trouble understanding the more advanced lessons. Hey, what's going on, everyone? If you're new here, I'm Mark. Welcome to Car Audio Fabrication. Here on this channel, together we learn how to master car audio and how to design, build, and install our dream car audio system. Now, a quick side note, I recently did a poll here on the channel to see what topics you guys would like me to cover more in detail, and a very common theme was OEM integration. So that's why we're starting here, because in order to understand some of the more advanced topics, we need to understand these basic terms. We're going to start slow with some terms that I'm sure a lot of you guys are familiar with, but we're definitely going to get into some more advanced terms that you may not have heard of. So first off, the head unit. I just want to define this right up front because it's kind of a term that's used interchangeably with the infotainment system, the radio, the stereo, the head unit. These all kind of mean the same exact thing. It's that main unit in your dash that you're actually interfacing with in order to turn up the volume or to change the music track. In modern systems, it obviously has much more built into it, which a lot of times leads to us not being able to even replace it because there are so many different vehicle settings and everything integrated into it as a unit. The next term we already covered, line output converter. There are obviously many different options on the market, and the unique aspect of a line output converter is a lot of times these more recent amplifiers have a sort of line output converter built in, where it will allow you to connect the high level, speaker level signal directly into the amplifier, and it does that conversion process internally. With a line output converter, you're really not manipulating the signal in any way other than just changing from a high level to a low level signal. Again, obviously there are many line output converters on the market. Some allow you to have some different OEM integration options. We're going to talk about that in a second. But the point is here, this is kind of the bare minimum for OEM integration. As we start to get into some more advanced OEM integration, we might be using a device that is called a DSP. And a DSP stands for digital signal processor. What a digital signal processor allows us to do is take the incoming signal and we can control it and tune it in many different ways in order to impact the overall performance of the audio system. There are lots of different things we can control on that signal as it goes through the DSP. First of all, we can control crossovers, which allows us to limit the amount of frequencies that goes to each of the different speakers on each of those output channels of the DSP before it is sent to your amplifiers. We can also control a setting called time alignment. In layman's terms, what time alignment allows us to do is delay an audio signal for a speaker that is closer to us. That way, that signal is arriving at our listening position at the exact same time as a speaker that is further away from us. The reason for doing this is the speed of sound is actually relatively slow. It can actually impact the performance of the audio system to have proper time alignment done and tuned on your system. I actually have a full video all about this that I recently did here on the channel. I'll put it in the card up there in the corner of the screen. The third main thing that a digital signal processor controls is EQ or equalization. If we take a speaker like this Gladen Audio Zeta 6.5 inch and we play it in an anechoic chamber, which means there are no echoes in the chamber, we may be able to achieve a nice flat performance as you go through the frequency range that this speaker driver will play. Of course, no driver is perfect. They're all going to have slight deviations, but the point is, once you take this and put it into a vehicle, all of those different echoes and the vehicle space itself is going to impact the performance of those different frequencies. Some are going to naturally be louder and some are naturally going to be more quiet. Again, I'm using layman's terms here to break this down for you guys, but what an EQ or an equalizer in a digital signal processor allows us to do is to correct that actual audio performance, what we are hearing at our listening position. Now here's the thing, a lot of vehicle manufacturers actually have a DSP built into the vehicle that has a locked equalizer, a locked time alignment setting, all of these different settings that I'm describing. It's all locked within their DSP chip. You can't actually change it as a user, but the reason they do that is to make the vehicle sound as good as it can with those factory speakers. So obviously, once we start changing aspects of the system, like upgrading to aftermarket speakers, we're going to also want to be able to control and change that tune, and that's why we add an aftermarket DSP. A couple more things I want to mention really quick on the DSP before we move on. First off, if you want to go more into detail on DSP stuff, I have a ton of videos here on the channel. But second, it's important to understand that that term DSP is really used anytime there is any sort of digital signal processing. So a lot of times you will see a aftermarket head unit that has a DSP built in, and it does have some capabilities to change equalization, to change time alignment, to change crossovers. But what's important to understand is a lot of times with a dedicated standalone DSP box that sits between your source unit and your amplifiers, a lot of times you're going to have a lot more control in that dedicated box. It's also important to understand that there are other DSPs out there that are called integration DSPs. And what these DSPs do is connect purely to the factory audio signal, and they're just going to correct it and make it electrically flat, which is important to understand. That doesn't mean acoustically flat, that means electrically flat, and that gives us a flat signal that we can then use on our aftermarket gear, like an amplifier, or again, have another DSP that allows us to actually tune the audio signal for our car audio system. And DSPs can even be built into amplifiers like this Mosconi Pico 8-10. Now real quick, you may have noticed that I'm rocking my New Concepts hoodie here, and that's because this episode is sponsored by New Concepts. New Concepts has a wide variety of different power wire, power distribution parts. They're really my go-to source for all car audio wiring, and I wanted to show you guys this. This is one of their latest cables that they've released. So if you guys have watched the channel before, you know that I love using this lineup. This is the Crystal series of RCA wires from New Concepts. But what's really cool is they actually have this 4-channel cable that you can see right here. So rather than having to run 2 separate wires, 2-channel wires, you can actually run this single cable and have these 4 different channels that you could send from something like a head unit to your amplifiers, head unit to DSP, DSP to amps, lots of different options there. What's really cool is they are color coded as well so that you can easily identify each of the channels. But this particular cable right here is a new length that they've added to the lineup. This is only 2 meters long, which gives us a lot more flexibility to some of the other existing wiring lengths that they have available. So don't forget, when you're planning your next car audio install, obviously you're going to need some wire and some different cables. So definitely be sure to check out our show sponsor New Concepts at the links down in the video description. All right, so moving on here, the next term that we need to understand for modern car audio integration is a load resistance device. So here's the deal. A lot of times when we're upgrading to an aftermarket car audio system, we actually need to disconnect the factory speakers, and we're not always going to be powering those with the factory system anymore. A lot of times we are instead taking that electrical signal and sending it to our aftermarket amplifiers, DSP, etc. But here's the unfortunate problem with that. A lot of times the factory source, whether it be the head unit or a factory amplifier, it actually actually doesn't like the fact that it's not seeing a speaker load connected anymore. This is why you need a load resistor. Audio Control has this right here, which they call an LGD, their load generating device. This is more than just a simple resistor, and in layman's terms, what this does is it provides stability to that factory system. When you have one of these connected between something like your line output converter and the factory system, or your DSP in the factory system, your amplifier in the factory system, it basically kind of simulates a speaker still being connected. And what it does is it makes sure that you're not going to have issues with the factory system muting the signal because it doesn't think that a speaker is attached. Worth noting here, because I mentioned it earlier, that some of these line output converters now have different options on them. On a lot of the Audio Control line output converters, they now have a load selection switch built into these, which can achieve that same functionality. To understand the next term, I've busted out a subwoofer here, and that term is polarity. Now let's say that we're wiring up the subwoofer. Of course, we want to connect positive to positive and negative to negative. But let's say we did switch them. That would mean that we have wired out of polarity, or in other words, we haven't followed the correct polarity. What's important to understand about polarity when it comes to OEM integration is it doesn't only happen at the connections to your speakers and subwoofers. It also happens throughout the signal chain. As an example, let's say that we're connecting to the factory speaker level signal. We want to make sure that we correctly identify the polarity so that we're connecting positive to positive and negative to negative. The next term I'm going to refer to here is something that you may have heard used interchangeably with polarity, and that is the term phase. As an example, let's say that somebody has a subwoofer system with two subwoofers, and let's say they're experiencing an issue where the bass output just isn't very loud. Somebody might say, hey, you need to check and see if they are out of phase. What they mean by this is perhaps one of the subwoofers has negative connected to positive and positive connected to the negative, whereas the other subwoofer is correct, which means one subwoofer would be coming out while the other would be going in, and thus they would be canceling each other. The reason I want to bring this up though is what they actually mean by that is that the subwoofer is wired out of polarity. It's one of those weird technical things, but the phase actually has more to do with timing. If I'm sitting between two different speakers, depending on the frequency of the sound wave, I can actually have the phase relationship change if I change my distance between them, and I can actually have one of these speakers be out of phase from the other at my listening position, again, depending on the frequency. Again, we talk about this more in one of my recent videos here on the channel, but the point here is to understand that there are different degrees out of phase. Imagine, if you will, two people that are swinging on swings that are right next to each other. If they are swinging perfectly in sync together, then they are in phase. If they are swinging completely opposed to each other, then they are 180 degrees out of phase. But obviously there's other options where maybe one is just a few degrees in front of the other as they go back and forth, and that would be just a few degrees out of phase. So phase is the timing of sound, and it's really not super critical if you were to only have one speaker in a vehicle, but obviously we have multiple, so phase does become an important thing that we need to understand, and we'll talk about that more in advanced lessons in the future. Now, a quick side note, when it comes to subwoofers, if you are looking to do your own subwoofer enclosure build, I can personally assist you with a design blueprint that gives you all of the dimensions to make your next box. You guys can learn more about that on my website, CarAudioFabrication.com. The next term that we have to understand for modern day integration is ANC, which stands for active noise cancellation. What the vehicle manufacturers are doing is they are putting microphones throughout the cabin of a vehicle that are listening to the noise levels in the vehicle. Based off the noise that those microphones hear, what the speakers are doing is actually playing that sound out of polarity or out at different degrees of phase in order to cancel that noise out so that you're no longer hearing it. It's important to understand when a vehicle has this for aftermarket integration because unfortunately a lot of times the way those systems are programmed, if we add something like an aftermarket subwoofer, the system may interpret that subwoofer as being playing noise. And what that means is then it will try to play the signal that's being produced out of polarity from the signal that it's playing. It can lead to all sorts of crazy, weird issues where you get odd humming noises and such out of the system. And for many vehicles, the solution is to find those microphones and actually disconnect them, thus disabling the ANC system. We'll talk more about how you can identify if a vehicle has ANC in the future. Another thing you need to look out for is fake engine noise. This one is pretty self-explanatory, but unfortunately, again, what some of these manufacturers are doing is they're actually pumping in engine noise that plays over the audio system that makes it sound like you either have a more impressive engine than you actually do, or for a lot of these electric or hybrid vehicles, giving you more of that standard sound profile you would expect from a gas-powered vehicle. Now, the next terms that I want to define here and bring you up to speed on are for crossovers. Now, remember that every speaker in your car audio system is designed to play a certain range of frequencies. Obviously, we wouldn't want this 6.5-inch driver trying to play subwoofer bass or trying to play the super highs that are produced by a tweeter, so we need a crossover network that limits the frequencies that go to this driver. Now, there are different filter types that are part of that crossover network. First of all, you might have a high-pass crossover, which means you allow frequencies above a certain point to go past. So on something like a tweeter, you would have a high-pass crossover at, let's say, 5,000 hertz, meaning everything above 5,000 hertz is going to go to the tweeter. Next, you have a low-pass filter, which means everything below a certain point goes to the driver. And you may have heard the term band-pass filter. What that means is a combination between a high-pass and a low-pass filter, so you are restricting to a certain bandwidth of information going to that speaker driver. Here's a filter type you may not have heard of though, and that is an all-pass filter. An all-pass filter is similar to a high-pass or a low-pass filter in the way that you apply it at a certain frequency. And it can also have a slope, or in other words, the rate at which change occurs. But rather than making it where we can't hear the sound above or below a certain point, instead it changes the phase. Using all-pass filters is something that the car manufacturers will do in order to kind of negate some of the different cancellations that occur in a vehicle, which can allow you to achieve better sound in multiple different listening locations within the vehicle. Sometimes we may want to retain these all-pass filters, and other times we may not want to. Again, I have a full dedicated video about all-pass filters here on the channel you guys can check out. The point is, we have to understand that sometimes they are part of the factory system and we need to determine a way that we're either going to use them or not. Now, the next term here is bandwidth limited. What that means is sometimes there is only a certain range of frequencies that is available on a channel that you're trying to use for sending signal to your aftermarket gear, meaning it is bandwidth limited. An example would be, let's say that the factory system has a factory amplifier and it's powering a tweeter directly off one of the channels of that amplifier. It's going to have a bandwidth limited channel where it's only playing those tweeter range frequencies. Obviously, we want to understand if a channel is bandwidth limited when it comes to planning out and designing the rest of our aftermarket gear. The next term here is factory EQ, factory equalization. We kind of talked about this earlier in the video, but a lot of times the vehicle manufacturer will have a stock DSP built in that is applying an equalization curve already to the factory speakers. That would basically be the factory EQ. Obviously, I understand that sometimes on the factory head unit, you have the ability to change EQ. That's not what I'm referring to. There's actually an EQ built in if you were to actually analyze the electrical signal of each of the different channels. And a lot of times we want to kind of negate that EQ again because we are looking to have a nice flat electrical signal before we adapt everything for our aftermarket gear. Another term here, signal summing. So signal summing is when we need to take multiple different channels of information that may be bandwidth limited and combine them together in order to have a larger bandwidth of information for sending a signal to a new speaker or aftermarket gear in our system. Again, it depends on system design, but sometimes we may want to signal sum in order to get a full range signal that we're using for our aftermarket gear. The next term here, dynamic EQ, dynamic equalization. Again, I just explained about how sometimes the vehicle manufacturers will have equalization applied to each of the different speaker channels to make those factory speakers sound better. But the other thing that they'll do sometimes is as you turn up the volume or reduce it, that actual EQ curve will change. A common thing that they like to do is they'll make it so that as you turn up the volume, it will actually reduce the bass. You'll experience bass roll off, which is basically just a change in EQ of the bass frequencies. And they do that to protect those stock speakers so that they don't blow or become damaged as easily, but it's a form of dynamic equalization. The next term I want to make sure you guys are familiar with is CAN bus. So CAN stands for Controller Area Network, and it's basically a network protocol that's used within vehicles. In layman's terms, it allows different devices in your vehicle to talk to each other and communicate over data. As an example, in some of the vehicles where we are able to still install an aftermarket head unit, a lot of times we have to do so with a device that allows us to actually integrate with the CAN bus network, which is actually really cool because it allows us to do things like take a factory volume control that's, built into the cluster or built into the actual dash and still be able to use that volume control knob even on an aftermarket device. Now, another kind of data protocol, if you will, is what you may have heard of, which is called a MOST network, M-O-S-T. MOST stands for Media Oriented Systems Transport. So this is a high-speed networking standard that is used primarily by many of the luxury automaker brands. And essentially the audio signal from the source to the factory amplifier is no longer analog, but instead it's digital. It's ones and zeros transferring back and forth. In layman's terms, the audio signal has basically been digitized. Now, there are various different types of MOST networks. There's MOST 25, MOST 50, MOST 150, and that number at the end corresponds with the bandwidth of the network. Now, the advantage of these networks is that if we can intercept this signal, usually it's a very nice, clean signal that we can use, but we need an aftermarket dedicated device that will allow us to do so. Now, thankfully, there are some aftermarket solutions on the market. A few examples are from nav-tv along with Mobridge, which, by the way, if you guys would like to see some of those devices here on the channel in more detail, be sure to let me know. Now, another network standard that you may have heard, kind of like MOST in a way, is A2B. This is becoming more and more popular, and it means Audio Automotive Bus. So this type of network communicates through unshielded, twisted pair copper wires. The advantage here being that it reduces the overall weight of the wiring along with the complexity, but it still allows communication for noise cancellation, infotainment, and other systems within the vehicle. Now, once again, there is a solution that allows us to interface with this type of system, but it comes through the use of a dedicated integration device. Overall, lots of different integration terms here to understand. I'm sure that there's some that I missed, and I'm sure that this also may have raised some questions along the way. So if you do have questions, be sure to post them because that gives me a better idea what I should address in the future. For your next car audio project, you're of course going to need power wire and different cable. Be sure to check out our show sponsor New Concepts along with their new length of the 4-conductor RCA cable. Check them out down below. A special thanks to Jerry and the rest of the Patreon membership team for making these videos possible. And as always, my friends, thank you guys so much for tuning in and watching.